Hello everyone, and welcome to the Numpy Exercises Solutions lecture. In this lecture, we're going to manually code the solutions for the Numpy exercises. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, so here I am at the Jupyter Notebook. Let's go ahead and start with just importing Numpy as NP. Hopefully you're able to do this one easily since the command is basically right there written out for you. I'm going to do Shift-Enter, import Numpy as NP, and we're ready to go. Okay, first we wanted to create an array of 10 zeros. An easy way to do this is to just say np zeros and then pass in the digit 10. And that will output the exact array that I had there as the output. In order to create an array of 10 ones, you can do the exact same thing, except instead of using zeros, you use ones. Then you just pass in 10 and you have 10 ones. Now to create an array of 10 fives, there's actually a few ways to do this, but one easy way is to just say np ones, and then you can go ahead and times it by 5. And that will get you an array of 10 fives. Another way you could have done this is say np of zeros, 10, and then what you could have done is add 5 to that. And those are probably the two simplest ways to create an array of 10 fives very quickly. Alright, now we wanted to create an array of integers from 10 to 50. Hopefully, seeing this as the output made you think of the arrange function, since that's the easiest way to do this. So we have np arrange, and we want from 10 to 50. And that means we want to start at 10 as our first input, and since we want 50 included, remember since indexing starts at 0, we have to go to 51 when we enter that, and that gets us the output integers from 10 to 50. The next thing we had to do was create an array of all the even integers from 10 to 50. That's also pretty straightforward. Hopefully you remember from the lecture that as a third argument, you can do Shift-Tab here if you want the actual argument, but you can add a step size. And since I want even integers, I'll go ahead and put a step size of 2. And then I get all the even integers from 10 to the number 50. Okay, moving along, we wanted to create a 3x3 matrix with values ranging from 0 to 8. This is going to be a bit of a two-step process. You're going to first create using arrange. You can pass in a 9 here, and that will create the array 0 to 8. And since I want this to be a 3x3 matrix, what I can do is I can say reshape 3, 3, and that produces that 3x3 matrix of values ranging from 0 to 8. Now you could have also split this up into two steps, meaning I could have said something like A equals np arrange 9, and then said A reshape 3x3, and that would again done the same thing just in two very clear, distinct, separate steps. But a lot of times when you're working with NumPy, you'll just kind of tack on these methods on top of each other. Alright, next you had to create a 3x3 identity matrix. Hopefully you remember the command from the first lecture of NumPy arrays, but that is just I, and you just pass in one number since identity matrices must be square. And then np.I of 3 is a 3x3 identity matrix. Alright, coming up next, we wanted to use NumPy to generate a random number between 0 and 1. There's actually quite a few ways to do this, but probably the easiest is to just say np.random, pass in rand, and remember from the lecture that this returns random values between 0 and 1. So I can just pass in 1 here, and that returns a random value between 0 and 1. Now your answer may have been a little different than mine was, but that's because this is random. So you'll always get a different number every time you run this, but it should be between 0 and 1 every time if you just pass in a single digit as your argument. So again, np.random.rand returns a random number between 0 and 1. After that, we wanted to use NumPy to generate an array of 25 random numbers sampled from a standard normal distribution. Hopefully that was a key word for you to remember that you could call np.random.randn, and if we do Shift-Tab here, this returns a sample from the standard normal distribution, and that is basically the tack-on of the n there. So that I can put in a 25, and that returns an array of 25 random numbers sampled from a standard normal distribution. And note here, you can tell by the brackets that this is just a one-dimensional array of 25 numbers, not a 5 by 5. You can actually confirm that by putting shape here, and it just says 25 instead of 5 by 5. All right, now we wanted to create the following matrix, and pay attention to what this matrix is actually doing. It's a two-dimensional matrix. Note we can tell that from the two sets of brackets here. And it also goes from 0.01, and it looks like it goes in a step size of 0.01 additionally, all the way to 1. Now, there's actually two ways to do this. I'll first go through the way that's shown in the solution, which might be the easier way to think about this, and then I'll show the more clever way using np.linspace. So one way you can do this is say np_arrange, going from 1 to 101, and that first gets you this array, which we're not quite there yet with what we want. So then what we're going to go ahead and do is reshape this to be a 10 by 10 array, and then we're almost there, but notice that we're going from 1 to 100, so what I can just do is say divide this by 100, and that returns the array I had. Note the two double brackets, it's a 10 by 10 array, and it goes from 0.01 in step size of 0.01 additionally, all the way to 1. That's one way you could have done this. And that's the way that's shown in the solutions notebook. But another really nice way to do this, and hopefully this is the way that you were thinking about this to begin with, but you could also do linspace, and then note where you started from and where you were stopping from. So we're starting at 0.01, going all the way to 1, and these are actually linearly spaced, so I can then just say 100, and I'll reshape this as a 10 by 10 matrix, and that returns the exact same result as I have above here. So either of these two answers is fine. There's a couple other ways to do this, but these are probably the two most logical and straightforward ones. Either way is totally fine, and hopefully you're able to figure out one of these. This is a little tricky of a question, a little bit of a tricky question, since there's no clear pattern here unless you're actually paying attention that it goes 0.01 additionally, and then you also had to pay attention that it was double set of brackets, meaning it was two-dimensional 10 by 10. All right, let's go ahead and continue on. Now we wanted to create an array of 20 linearly spaced points between 0 and 1. All you have to do for that is say np linspace, and then we're going between 0 and 1. So I can go ahead and say 0, 1, and then 20 linearly spaced points, and that gets me the exact answer that I have there. All right, now we're going to be given a few matrices. It's actually just one matrix, mat, and what we want to do is ask to replicate the resulting matrix outputs. And again, you had to write your code here, otherwise you would have overwritten the output you're supposed to copy. So let's go ahead and start doing this. First off, we had to grab this section of the array, 12 through 15, and then 12, 17, 22 rows. So how are we actually going to do this? I'm going to clear this commenting out. First thing I want to do is call mat, and then I'm going to put a comma here, and let's take a look at the rows we want. So the rows I want start at 12, 17, 22. So that looks like these last three rows, meaning if I look at the index 0, 1, 2, I want rows 2 and everything past that. So 2, colon. Those are my rows, and let's go ahead and confirm that by just putting a colon here to select all columns in those rows. Whoops, had to run this cell. Okay, so I ran that cell, mat's been defined, and now I'm selecting everything, all columns from those rows. And it looks like we're good so far. Actually, you can see the subset here, so I'm good on the rows. Up next is I actually want to grab the correct columns. In this case, I can see that I want to grab from column 1, index 1, and onwards. So I'm actually just going to say 1 colon and run that, and that's my answer. I can see that it matches. So to break this down one more time, I go from row index 2 and everything past that, and then column index 1 and everything past that. I pass it in this sort of notation here. All right, let's go ahead and move on to the next one. Next one is I wanted to grab just the number 20. So if I take a look at mat again, I just want to grab the number 20. So let's go ahead and figure out where that is. It's right here in this case, meaning if I check out the row first, I'm going 0, 1, 2, 3. So it's at row 3. I'll go ahead and type that in. And then it's all the way at the last column, which is 0, 1, 2, 3, 4. Since indexing starts at 0, so if I say mat 3, 4, that gets me 20 out. Perfect. All right. Next, I wanted to grab this 2, 7, 12. Let me go ahead and see what my mat looks like. Here's my mat, and I want to grab 2, 7, 12. Let's go ahead and again break this down by rows versus columns. 2, 7, 12 looks like it's here. So I want to grab everything up to a certain number of rows, right? So I just want to grab 2, 7, and 12, meaning I want to grab up to, but not including index number 3. So this is 0, 1, 2. So I'm going to go ahead and say everything up to 3. Let's go ahead and confirm that just by putting a colon here. And here's 2, 7, 12. So I have the correct rows. Now let's just grab the correct column. And in this case, there is something important to note about the output. The output here has 2 brackets, meaning this is a 3 by 1. So there's 3 rows by 1 column. And that means if I just put in the column number, so if I were just to put in, for example, let's see, 0, 1, I would get 2, 7, 12 out. But notice the shape here. This is just a one-dimensional array. And in this case, as the output, I want 2 sets of brackets. So the only way to do that is by actually indexing using slice notation. So I have to say everything from 1 up to, but not including 2. And that may seem a little strange at first, but that's the way, if I go ahead and run this, I can grab it in the same format. Now I know that's not very intuitive, but that's the way NumPy works as far as grabbing that column chunk in the same form of this 2-dimensional bracket. Otherwise, you'll get it as a one-dimensional array. So again, just to clarify, if I just put in 1, I get the same numbers, but I only get them as a one-dimensional array. If I want this actual double brackets here, I have to specify to grab in between those 2 columns, which again is really just 1 column. So I know that's a little strange and not intuitive. And in fact, a lot of the times we're actually just going to be grabbing all the values as such. We won't really be doing this kind of same indexing notation. But just keep in mind, that's kind of the way NumPy works. Syntax is a little strange there, but hopefully that wasn't too much of a trick question for you, and you can play around with it a little more to figure that out. But again, don't sweat it too much if you weren't able to solve that one as far as getting it in the same format. All right, we only have 2 left here as far as grabbing stuff. Let me go ahead and run mat so we can see what it looks like again. Whoops. MAT. And it looks like I just want the last row here, 21, 22, 23, 24, 25. Okay, so there's a couple ways to do this. Probably the simplest way is to just say, go at the index 4 row and return everything. And there we have 21, 22, 23, 24, 25, and it matches. The other way you can do this is if you know it's the last row in the matrix, you could also do negative indexing, and that will actually return the exact same thing. However, I would recommend that you use 4 here, so it's a little more clear. All right, one more. Let's go ahead and show mat. Here we have mat, and it looks like we want to grab all the columns of the last 2 rows. But again, notice something here. I have the double brackets, so I want to use that slice notation. Meaning I want to go from row index 3 to 5, and then grab all columns there. And that returns the same values here. Again, this one's a little trickier than the last one we just saw, but hopefully the answer makes sense to you now that you've seen it. All right, let's move on to do the following. Let me go ahead and put a new cell in here so we can see mat. What we want to do is get the sum of all the values in mat. Well, there's 2 ways to do this. You can either say np.sum and then pass in mat, or what you can also do is say mat.sum, and you get the same answer. Either is fine. Next, you wanted to get the standard deviation. So hopefully you're able to figure this out either using the universal function np_std and then pass in mat. That would have gotten you that. And you could reference the link in the notes for the universal functions, or it's actually common enough that you could say np.std, or excuse me, mat.std, and it would have worked as well. Okay, finally, this little tricky one at the end, get the sum of all the columns in the mat. In order to do that, what you had to do is say mat.sum, and you had to specify an axis, which you could have seen if you did shift.tab here. It will return the sum of all the array elements over the given axis. In this case, you have to say axis is equal to 0. And that's how that works. That last one was a bit tricky since we had to put in the access code, but don't worry too much if you didn't get it, because we'll get a lot more practice as far as specifying the access, 0 or 1, when we start working with the pandas library. Alright, hopefully that wasn't too bad for you. Again, you can check out the notebook for all the answers and all the code that I just went through, and always feel free to post to the Q&A forums if you have any questions on anything I just did, and I'll be happy to give you a further explanation. Alright, thanks everyone, and I'll see you at the next lecture.